Hey all. I mentioned a couple of times in the last few videos how much I appreciated that the micro corruption CTF makes use of the MSP 430 processor. I thought that was a really interesting choice. And then it occurred to me this morning that I actually have a development board for the MSP 430. This was one of the Texas Instruments Launchpad devices that they put out sort of to be a competitor to Arduino. They released these in 2010, I think, 2011. I bought one back when they first came out because it was a low-cost platform to play with, but I never opened it. As you can see, it's sitting right here. So I thought, it might be useful in the course of these videos to actually have a real version of this device to play with. I'm sure there are probably simulators out there that we could just run locally, but I have it, and I've never had an excuse to use it. I guess there's always so much information available for Arduino. It seemed like, why would I go off and spend time just learning this platform in addition to trying to do whatever project I was doing? So I decided, let's see if we can go ahead and get this thing installed. In true fashion, I haven't learned or researched anything about this, so I have no idea what we're up against. But that's kind of the point of this entire adventure. So let's see. Let's go ahead first and see if there's any drivers we're supposed to have for it, or if Windows is going to automatically have what we need. Let's see here. I have a virtual machine running to just do this, so that's an added thing that could cause a problem. Not firmware drivers. All right. Well, let's see. Let's look and see what we can find about assemblers. How about we find assemblers and not instead of assemblers? There's these other ones. TI has to have something official. We're just going to search the page for assembler. Compilers, assemblers, and IDs. I'm sure any of these would work. Oh, I thought I was going to TI's webpage. I got fished. I got fished. It sent me to that. Look at that. Never can be too safe. It's one reason we work in a VM. So we got the GCC fully open source package. Complete debugger. CC++. Usually the GCC will have an assembler in there of some kind, I think. Debugger integrated. Disassembly level debugging with support for complex breaks. A lot of these have a debugger, which is promising. Debugger is kind of what we're using in the micro corruption. We're looking at a debugger. So sensors. All right, I think our best bets are either going to be these bottom two, the IAR embedded workbench or the GCC open source package. So I guess we want Oh, this is a paid software? Ooh, yeah, no, we're not doing that. Guess we're gonna have to try GCC. GCC open source. Don't know how this is gonna go on Windows. Well, I guess we're gonna find out. It says USB drivers in there though, so that's cool. Um, really? I need to log on to get it? I don't know if I have on my TI. Okay, so I finally realized that I finally got the account set up um, and was able to log in, and now we're finally going to download GCC, I think. One thing we forgot to do was I forgot to start the timer. So I'm going to go ahead and start the timer, even though we're a ways into this. I've got to get used to starting that thing right at the beginning. But so here we go. Let's see if we can actually finally download GCC for the MSP 430. Maybe. Just didn't register my click. And here we go, with the full thing downloading. Let's close out some of these tabs. So I'm pretty sure GCC comes with an assembler. Another thing we'll be able to do is we can actually write code in C and then see what it looks like once it's compiled into assembler, right? Like if we make a very simple program that just counts a loop, we can look at that, so it will give us a lot better idea of how the assembler language actually looks when compiled. And we can try that using different optimizations in GCC. So there's a lot of cool stuff we can do if we can get a compiler of any kind going, but I'd really like to get an assembler going. All right, we have GCC. Okay. What do we use to burn our program to? Well, it looks like GCC directly just did it here. They compiled it and then linked it and then ran it. Well, let's see if that would work. This GCC is going to be for the copy of GCC we have is not going to be a Linux copy. I don't think it would. It's going to compile for unless it has multiple targets. I don't know which targets were built into this. Target help. Ooh, are those all the processors we support? Oh, that's a lot of stuff. Oh. No. I thought it might be the processors that we support, that this version of GCP is compiled to target. You know what? Onward and upward. Let's keep that in mind, that GCC might just be able to do the assembly directly for us. This thing apparently came with drivers. I have no idea. Let's find out. I have a USB cable around here somewhere. It's in my lap. We're going to plug this sucker in. See what happens. You'll notice a lot of my philosophy on tech stuff and life in general is let's see what happens. Like, it's that is the wrong kind of USB cable. This is an old school. I forgot how long ago I bought this thing. This is a mini. Luckily, the kit actually came with a USB cable. And we're going to connect it to the virtual machine. All right. It knows it by name, so hopefully it's got the right drivers for it. We're going to go check out Device Manager. Device is ready. Where is it going to be? Sorry, I was like, what's that? Man, we saw it in a document somewhere. I closed those tabs. Human interface device. Where's my window at? Did I close it? Okay, I guess it's one of these. Looking for something that's using drivers written by Texas Instruments or something else. I don't feel like this device is here. I'm gonna reconnect this thing real quick, see if I see any change. Okay, the human interface devices, there was, new one does come up. Two actually come up, USB input device and HID, human interface device, compliant vendor device. Okay, I don't know why it's not using the drivers from TI. Maybe that was a separate install I was supposed to do. No, it was just that one installer. It said it included drivers. Installing it. What is CCS? CC Studio. Ah, this is going to be some kind of GUI. Okay. That's going to take a few minutes. So while we wait on that, let me just find an MSP 430. Let me just find an example. Just want like a really easy, something I know is going to compile. I want to know that like when I'm compiling it, it's if there's any errors, it's because of my toolchain, not or assembling it. It's because of my toolchain, not because of my code. So the problem is none of these are complete assembly codes. They're like the .global section. There's no .text section, which is usually where code is in assembly language. So I think I'm barking up the wrong tree here. Let me go back to these code examples from class. Those look like the cleanest thing we had. I mean, apparently that's the Fibonacci sequence, which is really depressing to me because I would not be able to write this in this eloquently, even in Python. So I think I have Visual Studio Code or something fun on here. Yeah. So let's try, shall we? I have no idea if this is going to work, but we're going to save this as test.s, and we're going to save it to my desktop. And so we saw this thing over here that says that we can compile with GCC. So I am doubtful. And we should just be -C they use. So what's the -C option? -C is compile and assemble but do not link. Okay. And those are errors. There's lots and lots of errors. Did I save that file funky? End of file, not at end of a line. New line inserted. But it says it. It says it did it for me. New line inserted. So there's still a bunch of other. It says first unrecognized character on line 2. On line 1 is a hyphen, so it's not liking these. It's not even recognizing these comments. So let's see if we remove all the comments, like a good programmer. Just remove all the comments. So this whole CEDLs thing, whatever this dude is using this code for is excuse me. Okay, let's go back to the drawing board. This is nice, but I'm not typing all that. Oh yeah, we had our program finished downloading. Hey, maybe that'll have some templates in there. This might have some sample code. Still have no idea how to actually flash this to the device. At some point through this, you might think like, wouldn't it have just been easier to just sit down with the documentation at the beginning and just read it? And you would you would definitely be right. Um, I just don't learn that way. Like if I read it, I won't retain it at all. So for me, I have to kind of, the more I struggle to find something, the more it sticks when I finally find it. So if you're not the same way, then some people like to just sit down with the actual, you know, um, RFPs or whatever. RFCs, not RFPs. I think this is all I need. All right, let's see what happens here. Sweet. All right. Let's try this code composer. Sure, we can use that as a workspace. How long until I forget where we put it? I'm like, where did I put that workspace? This application is not built for speed. Let me just say that. Oh, it's like Eclipse based, it looks like. Running in a VM isn't doing me any favors here either. Okay. All right. Oh, they got getting started videos, which I may end up having to watch. Support forum, import project. Let's see if there's any chance that it gives me templates or anything. Well, it sees the device on, I think. No, maybe not. All right, so this session is running. I would think it wouldn't be able to do a debug session if it couldn't find the device. I'm going to try this and see if it errors. Exactly. Okay, cool. So it is, the computer is seeing the device properly because on device 1 up here, if I click identify, it actually is able to establish a connection to the thing. So that's cool. And templates. You know what? I promise you I had no idea this was in here. Like I it's like, oh, look, all the things I needed to do came to a head right here. And that's like, that's how it goes, right? I was running in circles, looking at 100 wrong places, um, chasing down trees, shaking down trees that just weren't doing anything. And then suddenly, you hit that one thing that's like, kind of brings everything together. And I'm 100% sure you could probably just do this with the GCC command line if you knew more than I do, but I don't. So there's an LED on the thing. I'm assuming that's what it'll blink. It's actually blinking right now, so I don't know if I'll notice a difference. But let's see what happens. Let's give this a name, blinks, and gotta select a target. Oosh, this is, looking at the box here, does it tell me exactly what version of the MSP 430G223 430G. It looks like it's going to be this one. And I just got that off the back of the box in tiny little print back there. I'm sure it's in the manual and online. Oh, and then it wants detailed version. G223 1IN 14. C. Oh, G223. G22. This is 33. 2231. That's mine. I think. Oh, empty assembly only project. It gave us different templates. Damn. Gave us different templates when choosing this particular thing. Let's see if this identity thing still works. Okay, just wanted to make sure that. Didn't know if maybe when we changed the target that it might actually change how it was trying to communicate. Well, crap. This blink is probably going to be a C project. Oh, sorry, I have a cat now that wants some attention. Let's try the blank assembly only project. Let's see what we get. All right, we got kind of what I wanted though, which is this shell. This shell. So I mean, we should be able to. I don't know. Do I need to put a main in there? It's in this. It's in the text section already. I think I can just put main here as a label, and I'm guessing. So, and let's just say move an immediate value into R13. This code would effectively do nothing. I just want to see if it compiles or assembles, whatever. Oh no, I moved my screen. So every time I move the window that VMware is in, it does that. I haven't looked into why. All right, so let's see. Let's see what happens if we build it. Finish building. So that's cool. Okay, so we have a way to build assembly. Can I send this to the device? How do I actually send this to the device? This is kind of cool. There's like a whole debugger in here. So this might be a fun thing to continue exploring on its own. This would be kind of a where the rubber meets the road version of what we see in microcorruption. You'd see it in something like this. Okay, but how do I... Oh, we can look at the command line options to see what they ran too. So let's see what this actually did. Looks like it used its own version of a compiler. It said code model small, data model small. Defined that, basically set a define in the C language to specify to turn that on. Set some include directories. Yeah, we just would have needed to look into some of the command line options, I think, of the GCC more. So we might come back to that as well. Okay, so well, we still don't know. Gave us some optimization advice on a template with like one thing. Code's not optimal. Okay, how do I get this to the... Where does this load? idea what's happening. That's it. That was the flash. That was the flash. So just to make sure we know, I'm not going to pretend to know assembly well enough to actually write something useful to flash that LED right now. Again, that might be a great future thing to do. What I'm going to do is I'm going to make a new project that uses the LED blink, and that way we can just kind of we can make sure that like that actually is how we send stuff to the device, because that looks like it. It's saying it's used 38 bytes of uh, flash RAM and 0 bytes of RAM. So that looks like it's talked to the device. Is there a console? Well, this says console, but is there more details for a console? Um, so cool. Let's make a new project real quick. New project. Yeah, this is definitely Eclipse based. This doesn't have all the fun stuff that we saw in our getting started page. Click it from here. That's a very different world. Connection. I'll call this one really blinks. And we're going to make this blink to LED. So yeah, this actually sounds fun to me now to go through here and say, let's look at what the assembly comes out to. Not in this session, of course, but let's look at what the assembly gets created for this C code, and then write our own assembly to do this. I think that would be really fun. So we'll do that as another aside, I think. So pretty simple. I import the MSP430 specific header. It's like I think it's a bitwise OR. And then shift the bits to toggle it. I think that's shifting. All right, well, let's see. So let's build it. We got a warning. Bad when you get a warning on the sample code. Stack section size is required to be aligned to 4 bytes. Specified as 32 is not. The line size is 34. Okay. I'm not worried about that for right now. Let's do it. Flash RAM is 38 bytes, 0 bytes used. Well, there ain't nothing flashing on this board. But the power wasn't even on until I touched the button. Although, she ain't doing nothing. There's no flashing LED here. So I have no confirmation that code is actually on the board. Oh, you know what? I grabbed the one that was in the thing right here. Blinks. I was thinking blinks. That's what we named the project or I named the project. I'll take the fault here because I kind of have to. I named the project that was the assembly file. It does nothing. So I actually need to select this one. Jeez. So real blinks, debug, real blinks out. Let's try this one now. The ultra low power advisor checks for best practices. Okay. Go right ahead. says it's up to date. And we have a blinking light again. And that's great. After I flashed the assembly file that didn't do a blinking light, there was no blinking light on this thing. Now there is very much a blinking light. Do I have my little USB charger here? I don't. Problem is it's one of those old mini USBs, so I don't have one of those laying around long enough to run over here. So, or do I? I mean, my Ender 3 back there uses that kind of connector. But I'd have to yank the cable off of it. Just have to trust me, I guess. It did work. So, cool. So it took us a little longer than I expected it to. We went around in a very circuitous way to get here. But I'm pretty happy. Like, you know, we actually figured out a way to compile C code. Sorry, I have a cat here that wants attention. Both C code and assembly, we got that all worked out. We now have a platform where if we want to come play around with that, we have that ability. So I'm happy overall. This video is going to require a lot more editing than the last couple of videos, but yeah. So thanks for sticking with me. I hope you enjoyed something or learned something from it, even if you're just getting your enjoyment out of wondering why it takes me so long to figure out simple things. So thanks. Have a good one.